We are at Akron-Canton Airport, and we are going on a little plane ride in this guy. So we are headed to Hartzell Propeller. We're going to learn how propellers are made. Nice flying.
Hey, welcome to Flight Test. I'm Josh. One thing, whether it's model aviation or general aviation, that's a very common thread, is how the plane goes through the air, and that's oftentimes done through something called a propeller. We got the great opportunity recently to partner with a great company named Hartzell Propeller. This year, 2017, is actually the year they're celebrating their 100-year anniversary, and the very first customer they ever had was Orville and Wilbur Wright. One of the greatest things about any company is its people, and we got to meet up with two exceptional people from Hartzell Propeller, JJ Fridge, the Executive Vice President, and Trevor Parker, the props and integration engineer. These two gentlemen not only showed us how props are made, but more importantly, how they work. Now, one thing you may picture when you see a propeller is just a simple common plastic piece, a solid propeller like you see here, or even a propeller off of my 1928 Pete and Pull. This is what they used to look like. But Hartzell actually does a completely different thing with their propellers, something called constant speed. The neat thing about constant speed props is it gives you the ability to change the pitch to get the best climb and then the best cruise. They do this actually by changing oil pressure inside the prop and actually move the prop in midair to make that engine perform at maximum efficiency and then be able to change flight modes as you fly. One thing we learned about the process of making a propeller is efficiency and safety is very key. They do this by something called one and done. One and done is where they actually make a part, test a part before it's passed on for inspection.
This is a good example of done in one manufacturing. The principle is run a part, check a part. You basically load in a hunk of metal, call up the program that you want to run based on the raw material you put in, and that's going to run through its cycle and put it on the CMM here to do the laser inspection. It's given the readout here on the computer screen. If everything is green, that means you're in tolerance, and go ahead and put it back into the spindle for the finish operations, and then you'll check it again.
We learned because the props have to move in midair, there has to be different ways to mount the props to give them the ability to move.
What we're cutting over there is what we call aluminum hubs, and that's the clamp style hub where the blades nest in the hub and they clamp down over the top of the blades. This is the other style hub we make, which is called a steel hub. It's actually heavier. It's for some dirtier engine applications. The blade will nest on the pilot tube, butt up against the hub, and then we'll clamp it down with clamps around the outsides.
A lot of the ag planes that used to have monster radial engines and they switched out for a turbine airplane with more power, they end up using a steel hub instead of a lightweight because they need that weight hanging out there to get it to balance properly.
I'm not that muscular. After learning a lot about the hubs, we learned a lot about how the blades are made.
So this are all of our blade forgings. We have about 10 to 12 different blade forgings that we use. And then we cut those into about 500 different finished part numbers for blades.
Really?
These aren't what you would call like a near net shape. So it's not that it's the shape of the blade plus a little bit. They've been designed so that we can fit lots of different shapes in them.
Inside of them.
So you wouldn't take one of these and just kind of round the edges off to go fly it. It's been designed to put 50, 60 different designs in it.
A common plug that can hold 3 or 4 different designs each time.
Yeah.
That's really cool. The very first thing they cut is the shank, and from that point on, the prop is going to be manufactured from the shank on outwards. What is that machine doing right now?
It's actually sanding the blade to finish dimension, and when we cut the airfoil, it'll leave it with a small step over from the machine that we actually need to polish or grind off, and that's what we're doing here.
And that was all done manually at one point?
Yeah, this used to be about 25 guys grinding blades.
Wow. So you guys are all about safety. I gotta imagine the tolerances you guys can get now are much greater than what used to be, huh?
Yeah, the consistency and the tolerance is much greater than the manual operation. We've been able to redeploy those folks to other parts of the company to manufacture other parts.
I love the fact that you bring technology in, you don't take people out of it. They're all
that's our key. That's our key operating philosophy, is that we do it for quality and for efficiency, but then we redeploy so we can manufacture more parts in-house.
That's why you have people here forever. That's awesome. Even though there's a lot of use by robots, there's still some things that people have to do, and they have well-trained professionals to be able to do that by hand. Now every single item on a propeller needs to be tested out, all 120 pieces. If it's a component that's magnetic, it can actually be tested through magnetism to find any faults. But if it's something like aluminum where you can't test it for magnetism, they have a really unique process that involves a black light. The parts are cleaned, they're dried, and then there's a developing agent that under a black light will reveal any faults that you may find.
You can see how that powder, the fog of it, trying to pull it back out of there. That's a very extreme example. I don't, usually find things like that, but
Every prop, every main component is tested this way.
Yep.
One thing about a propeller is it's nothing but a wing airfoil that spins around very fast. But because of that, you need to keep ice from being able to form on the leading edge. In certain conditions, ice can form on the leading edge, and that destroys the integrity of the airfoil to give you lift. So what's this room right here?
So this is our boot room. It's humidity, temperature controlled. It's where we put on all the de-ice boots for any prop that's going to have de-ice capability. It takes a little bit of heat, plus the centrifugal force of the prop spinning around and the CF load to shed the ice.
Gotcha. Once all the components have been made, we moved on to the assembly area. The assembly area is where we're going to take all 120 plus of those parts, put it all together, and test it out thoroughly. Now, because the propellers change pitches, there has to be tests to make sure that they're going to hold up for a long time. One way that they do this is they actually apply sensors or little nodes all over the props, and then they put them on an airplane and fly them for many hours, taking them through those transitions and seeing how the vibrations interact with the different materials, both steel and composite. After we learned how propellers are made, we got the opportunity to actually see how they're overhauled.
We will check all the metal parts through our NDT process again that we showed you, and we'll look for any sort of dimensional areas where we're out of spec, or we've got wear. We'll run that through our engineering group.
So these props really go through many of the same processes it takes to create the prop in the first place, just to be rechecked and reconfirmed?
Yeah, a lot of the same, especially the finish operations. We do a complete tear down and inspection, and then we'll send them through quite a few different refurbishing ops, and then of course, we'll prime and paint the blades and prime and paint any of the other components that get painted as well. Yeah.
After we got to see how the props were repaired, we got to see the shipping area. Oftentimes if a prop can't be repaired, they want to make sure pilots can get in the air fast, and this is where the shipping area comes into play.
We try to stock around 100 propellers at any given time because you never know when your prop goes in for overhaul, you're going to get that dreaded call from the repair shop that says, hey, you got 2 blades and a hub that are going to go scrap. It's going to be a lot more than you thought it was going to be to overhaul it. You want to just buy a new prop.
Yeah.
And so the customer then has choices. They can choose us, or they can choose one of our competitors, and we want to have those props in stock so that we can ship out within a day or two and get that new prop to the end user so that they can get it on their airplane. So
your boxes are as unique as your business.
Yeah, right.
That is really cool. It was a really amazing experience getting to see how a propeller is made, from raw materials all the way up to the finished product, and even some steps in between. But what really inspired us was the people. One key slogan that we saw posted everywhere was the slogan said, "Built on Honor." Hartzell's had that motto for over 100 years. And one thing, they also incentivize people to be passionate about flight. Hartzell encourages their employees to become pilots as well. And we even got the opportunity to actually go to the hangars and see some of the employees' personal aircraft. Friends, I want to sincerely thank you for watching, and I really want to thank Hartzell for making this episode possible. One thing with general aviation that we need is great partners to come along and showcase their passion for aviation. If you're a company or entity that would like to do the same, there's a link down below to a form that you can fill out, and that way we can get in touch with you and hopefully partner with you and share your passion for flight. We'll see you next time.